This demonstration illustrates differences in alpha, beta, and gamma radiation. We have 3 different sources as well as a Geiger counter. This first source is an alpha source, and so therefore it's going to emit alpha radiation. We are going to turn on our Geiger counter, and you can hear that there's a few clicks. You can also see that the light is flickering, and this indicates that there are alpha particles being given off from this radioactive source. We're now going to compare that to a beta source, and we can hear and see that there are significant more beta particles being given off. And now we're going to compare this to the gamma source. The gamma source also has a significant more clicks and flickering, again indicating that there is a large number of gamma particles being given off. Now what we're going to do is we're going to look at the penetrating power of each one of these sources. And so we're going to place 0.05 centimeters of aluminum in front of our alpha source. And now we're going to try and detect those alpha particles. We can see that there's a small amount of radiation being given off, and that is because alpha particles are easily blocked. However, we're also likely getting some background radiation that's also being detected by our Geiger counter. We're now going to place 0.25 centimeters of lead in front of our alpha source. And we should notice a difference in our number of particles that are being detected. However, again, we're still getting some background radiation. So let's now look at the beta particles. We're going to again start with 0.05 centimeters of aluminum. And some of those particles are definitely penetrating through the 0.05 centimeters of aluminum. And that's because beta particles have a higher penetrating power. In comparing to the blocked and the unblocked beta particles, we can see that there are definitely more particles being detected now. We're now going to use 0.25 centimeters of lead. And you'll notice that there's a significant decrease in the number of particles that are being detected. We're still detecting some because beta particles have an intermediate penetrating power. Now we're going to detect our gamma particles. And the gamma particles have the highest penetrating power. So we're going to compare our 0.05 centimeters of aluminum. And you can hear that there's a significant amount of radiation penetrating through the aluminum. We're now going to compare to the 0.25 centimeters of lead. And there's very little difference. And this is because gamma particles have such a high penetrating power that it actually takes 10 centimeters of lead to be able to block the gamma particles.